Thank you very much. My first time to Hong Kong. Is this a little bit too loud? Is this okay? It's bizarre. I'm hearing myself. So this is my first time to Hong Kong. It's a delight to be here, and I'm a little bit jet lagged, so I will do my best. So I'd like to, this is really not too loud. Can I turn it down just a little bit? How do I do that? Can someone help me?
Here. It's here.
Hello? Okay, that's good. That's good, that's very good. All right, I'm going to put the audience in the dark. Great. So I'm delighted to be here. It's my first time to Hong Kong, and I would like to get some walnut shrimp for dinner at some point here. And I've learned that's maybe not really a proper Cantonese dish, but it is one of my favorites. So this lecture, Why Does Ramanujan, the Man Who Knew Infinity, Matter, has a little bit of mathematics, a little bit of history, and as Professor Mock was saying, it has a lot to do with things that are very close to my personal story. So perhaps unlike any lecture you'll ever hear me ever give, maybe this is the one, maybe this is the lecture that kind of matters the most, at least for me. So I first learned about Ramanujan when I was in 10th grade. A letter came to the house. It was Saturday, April 7th, 1984. I grew up in Baltimore, Maryland. My father was a mathematician at Johns Hopkins. Maybe some of you know about him. But what I have to admit is, growing up, the last thing I ever wanted to be was A, a mathematician, and B, probably nothing like my parents. And that started to change on this day. It was a very strange letter. This letter came to the house. You can see it's literally just a form letter, and it begins with the words, "Dear Sir, I understand from Mr. Richard Askey, Wisconsin, USA, that you've contributed to the sculpture in memory of my late husband, Mr. Srinivasa Ramanujan, and I am happy over this event, and I thank you very much for your good gesture and wish you success in all of your endeavors." So I was the one that pulled this letter out of the mailbox. I gave it to my dad, and I didn't think anything of it until a few hours later when my father comes to me, basically with tears in his eyes, explaining that this letter was really very important to our family. I looked at the letter, it was a form letter, and all I could think of is that that's really weird. First of all, it's a letter written by the widow of a man who died in 1920, it's a long time ago. A man who was somehow a mathematical genius. I'd never heard of him before. And I thought it was just very weird. What I remember quite vividly, though, is that my dad said, "You're not going to believe the story of this person. This is a man whose ideas came to him as mathematical visions from a goddess, and lots of mathematicians all over the world look up to his formulas and his personal story for inspiration." And I thought that was just the weirdest thing. And then my dad went on to tell me that, and you're not going to believe it, this guy couldn't even graduate from college. He was a 2-time college dropout. And when you're a 10th grade boy being told you're supposed to get very good grades and high test scores, it's like a godsend to hear your parents say, "Here is a 2-time college dropout that is like a wonderful role model." So the story behind this letter is also something that I think I need to tell you. It turns out that Ramanujan, as you can see, was born in 1887, and by the early 1980s, the mathematicians of the world, in particular the mathematicians in India, were getting ready to they're preparing to celebrate the 100th anniversary of his birth, which already says something. If they celebrate the 100th anniversary of your birth, you matter. But what inspired this very strange letter, because as you can see, my father was one of maybe 80 or so number theorists around the world who helped pay for a statue of this man, a man they never met. Turns out that a reporter for The Hindu, I think the New York Times of India is a major daily newspaper, thought that, well, maybe Mrs. Ramanujan's widow, maybe she's still alive so many decades later. So he looked for her, and amazingly, he found her living in the slums of Chennai, formerly Madras. And it turned out that she'd ended up living 6 decades in poverty as the widow of a great man. And the reporter thought, how could this have happened? This man Ramanujan was one of our country's heroes. How did that happen? So in any event, she was quite graceful and gracious for having the opportunity to remember her husband. And instead of complaining about her situation, she just asked, well, my husband died in 1920. The government promised to erect a statue in his honor. Where is the statue? And Dick Askey started this fundraising drive among the mathematicians of the world, and the mathematicians gave Mrs. Ramanujan the statue. I think it's a lovely story. So for me as a 10th grader, nothing about mathematics really seemed like it could be so beautiful as a human story. Then there's stuff about visions from goddesses, and none of it made sense. Someone should have made a movie about it. And so that's how I first learned about Ramanujan. It's kind of an incredible thing. My friend Amir Axel, who recently passed away, we wrote a book together about my family's relationship with Ramanujan. So if you're interested in that, feel free to get it. And so now let me begin with the main part of the lecture. As was mentioned earlier, we made a film called The Man Who Knew Infinity about Ramanujan. It starred Dev Patel, who doesn't look anything like Ramanujan, as you can see, and Jeremy Irons, who plays another one of the protagonists. He played the famous English analyst, G.H. Hardy. And what can I say about that? It was super fun. I had the opportunity to spend actually 3 years of my life working on this project. If you're wondering how long does it take to make a film, well, it takes 8 years to make a film about a mathematician. There's nothing easy about making films, and there's certainly nothing easy about making a period film about a mathematician. But my friend Matt Brown, who was the director and screenwriter, it was his passion project, and through sheer effort he made it happen, and after 8 years this film was made. And I came onto the project shortly before filming started, and it's one of the most exciting things that has ever happened. When you earn a PhD or study mathematics, you never think that you're going to be hanging out with like Johnny Depp or Anna Kendrick. And there was a short period of time where that actually was my life. It was crazy. What I like about the film, The Man Who Knew Infinity, is that it had an impact on the cast. When Jeremy Irons and Dev Patel signed on to make this film, it was just supposed to be the next film in their filmography. But it turned out to be nothing like that. As many of you probably know, Dev went on to become the star actor in the film Lion. He was nominated for an Academy Award. Jeremy Irons has done it all in Hollywood. Certainly now, because he has now played a Cambridge professor. But the story of this Ramanujan, who inspired so many people, inspired Jeremy Irons to travel with us to promote education. He took time out of his busy schedule to travel with us to talk about the importance of math and science. And I thought that was incredible. So here is a picture of us at the White House shortly before the last election. And President Obama had arranged for a screening of the film at the White House. And here we are filming a little segment for the citizens of the United States. It's a math problem. And the problem that we're trying to get people to answer is, what is the smallest number that is the sum of two cubes in two different ways? What I love about this is Jeremy Irons is a super cool actor. On the left is France Cordova. She's currently the director of the National Science Foundation. And I have no idea how I ended up in this picture at all in the first place. But it was really something for us to have Jeremy Irons on hand to to talk about, look, I'm not any good at math, but I know we live at a time where the future depends on cultivating young minds. And I thought that was just absolutely awesome. All right, so who was Ramanujan? Well, that's what this lecture is mostly about. So let's get some of the main biographical facts out of the way. Ramanujan was born in 1887 in South India, the state of Tamil Nadu. He was a Brahmin. He was a member of the priestly caste. So most of the Indians that I know that have come to the United States to work in science have been Brahmin. And although I've already told you that he was a two-time college dropout, make no mistake, he was brilliant. So as a young boy, he was an outstanding student. He won academic awards, and he even earned 2 scholarships to college. If you ever visit India, which I recommend that you do, it's a beautiful country. Colors are beautiful, the people are very warm. It's very exotic, certainly for someone like me. If you visit his hometown of Kumbakonam and visit his high school and make an appointment to meet with the principal will show you awards that Ramanujan won when he was there. It's really something else. And as the story goes, he did a lot of his mathematical exploration on his own. He lived, quite frankly, in his mind. And as the story goes, he discovered much of trigonometry by himself by the age of 13. I mean, who does that? It's not, that's already quite unusual. What I like about Ramanujan is that when he learned that trigonometry was not his invention, he took his notebook, he threw it on the roof, swore he was never going to do mathematics again, but, well, he just had to wait. What I like about that is it shows this confidence that he had that you will definitely get glimpses of if you ever take the time to look at some of his notebooks. So life for Ramanujan really took a major turn when a friend gave him a book called A Synopsis of Elementary Results in Pure Mathematics by a Cambridge tutor by the name of G.S. Carr. This is not a remarkable book in any way, but for Ramanujan, this might as well have been his Bible. How is this book described? Well, it's described as follows. It's a book that contains enunciations of 6,165 theorems, systematically and quite scientifically arranged, with proofs which are often little more than cross-references. So this book ignited Ramanujan's passion for mathematics, and he started to come up with his own results that he recorded in notebooks. And what he did was he emulated the style that he saw in this book in his own notebooks, which meant that there were hardly any words, and there was actually very little organization to the content. So I have to tell you a little bit about what this book looks like, and it's actually very easy to do without showing you some images. The very first line in this book is a formula, and it's the formula that says A minus B equals A minus B. So I have 6,164 to go. The second formula says A squared minus B squared, you probably know the rest, equals A minus B times A plus B. That's the second one. And the third one is A cubed minus B cubed. And aha, now something happens. For those of you who remember your high school algebra, you remember, oh, A cubed minus B cubed is that's like an idea. It's the beginning of an idea. That factors as A minus B times A squared plus AB plus B squared. But once you see that, you now know how to factorize A to the fourth minus B to the fourth. And in this book, then there will be vertical dots, and then the sentence, and there's a general pattern for all that. And that's the format that Carr used throughout this book, where the user of the book had to fill in the details. And I think that Ramanujan found that as a way of learning by doing. For me in 10th grade, it would have been video games, and I don't know anybody that can make a living by, well, maybe you can make a living these days by playing video games, but certainly that was not possible when I was growing up. So this is where I had to tell you about some of my own personal experiences. I've been to India many, many times, and on several occasions I have taken the opportunity to visit the University of Madras Library make an appointment, have made appointments with the librarian, and I say, I want to see Ramanujan's notebooks. Now, these notebooks have been reproduced, you can buy them, and they've actually even been edited, but that's not the same as going to the library and having the librarian bring out for you these 3 notebooks and flipping through the page. It's really kind of an incredible experience, because you get to hold the notebooks that Ramanujan recorded his findings in. He had beautiful handwriting, by the way, but that doesn't actually help you read or comprehend many of his formulas, and it took basically 100 years for people to finally complete the task of editing these notebooks and another one which is often referred to as a lost notebook. And these were smart people trying to figure out these 3 notebooks. They worked very hard to finally edit and make sense out of these formulas. Let me add to it, although there are 3 notebooks here, there really are only 2. The 3rd notebook is almost empty, and in fact maybe there's only 1 or 1.5. It turns out that the 2nd notebook is an enlarged and edited version of notebook 1. So now it makes you wonder, what's in this book that it takes 100 years for people to figure out? All right. So Ramanujan became obsessed by mathematics, filling up these notebooks, and he started to spend all of his time doing math. And as a result, he flunked out of college. He did it twice, so I don't recommend that you do that. And to try to describe how he did his mathematics, unless you are Hindu, you might not understand, but Ramanujan would visit his family temple, which was right down the street from the house he grew up in, where his mother sang, and he spent a lot of time in his temples listening to drums, sitting on the warm stone floor, scribbling away on the slate, and occasionally making a new addition to his notebooks. As a 2-time college dropout, life could have been difficult, but to his parents' credit as well as others, he found a job as a clerk, and so he was able to make ends meet. But one thing is absolutely sure, he might as well have been living in a desert if he wanted to share his mathematics with anyone. Nobody could understand his mathematics, and so he was lonely. All right. So I said we made a film about Ramanujan, the man who knew infinity, and what I'd like to do is show some clips along the way to help me tell the story, because professionals do a lot better job of telling a story than I would ever do. So in this first scene that I want to show you, and maybe I'll talk a little bit about how you make films. This is now kind of a part-time job for me. I'm actually a member of the board of the Infinity Film Foundation, or maybe, let me not get into that. But I'd like to give some indication of what we were thinking when we were writing some of the scenes. I think it'd be very interesting. So the scene I'm about to show you had several goals that we had to achieve. And the first goal was we had to introduce a new character, Ramanujan's wife, Janaki, who wrote my dad. By the way, Ramanujan married Janaki when she was 9, and the first thing you're going to figure out is that our actress Devika was certainly not 9. Well, what else do we want to achieve in this early scene? We want to make it very clear that the audience feels for Ramanujan, sympathetic for what it must be like to be desperate to have a friend, desperate to have someone you can share your passions with. And then this was the hardest thing, what basically almost made this film not producible, was how in the world are you going to explain to an audience that mathematics is A, worthwhile, and B, beautiful. So this is how we did it. I'll let you watch.
Go ahead. You can look. Please.
What does it all do?
It's like a painting, I think. Only imagine it is with colors you cannot see.
What good is that?
Not much for you, honestly, but for me it is is everything. Maybe there is someone else who can see and understand it as well. And for them it will be important.
Have you met them?
No, not yet.
I want to understand more than just colors I can't see.
What do you see?
Sand?
Yes? Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything. The color in light, the reflections on water. In math, these patterns reveal themselves in the most incredible form.
So that's what we were thinking. So Ramanujan reached out for help. He might as well have been living in the desert. He wanted to share his ideas with anyone. And so he was encouraged to reach out to mathematicians in England. He wrote letters to some mathematicians that never responded. Finally, he reached out to G.H. Hardy with a letter that begins with some very famous words. I beg to introduce myself to you as a clerk. I've had no university education. I've not trodden through the conventional regular course, but I am striking out a new path for myself, and the results I get are termed by local mathematicians as startling. Those are very humble, but also very confident words, which is why I like to read them. Here is a very famous image of G.H. Hardy. There are very few pictures of Hardy that have survived. He was very shy. He didn't like having his photograph taken. In fact, it's a very famous story that he would cover up the mirrors in the hotel rooms when he would travel because he couldn't stand to look at himself in the mirror, despite the fact I think he's quite handsome. So of course we chose a great British actor to play him, Jeremy Irons, and we had Jeremy reproduce that pose, and I think he did great. In fact, it's difficult for me to now view Hardy as anything other than Jeremy Irons. We screened the film in Princeton in the spring of 2016, and Freeman Dyson came. And one of the things I'll never forget is this was a lovely film. You got some things quite wrong, but one thing you did get right was you really got G.H. Hardy right. That man Irons really did that right. And I really like that. All right. So what was in this letter that Ramanujan wrote? There were some things that made people think he was utterly crazy. Maybe not in this audience, but let me show anyway. This letter included the very famous claim that the sum of the positive integers actually don't add up to positive infinity. They don't even add up to anything about infinity. They add up to negative a 12th, and that looks crazy. But it isn't crazy. Hardy was perhaps the right person to receive this letter because he, as an analyst, would have recognized the deep connection to the work of Riemann. And it turns out that if you study a part of complex analysis that involves a function called the Riemann zeta function, there is a way to make this formula almost correct. And so Ramanujan perhaps finally found someone who understood him, despite the fact that Ramanujan's device for obtaining this formula was very, very different from what we would traditionally use today. What else was in this letter? Let me teach you something that I think is really beautiful. So what is the value of this infinite continued fraction x, the one that's obtained by 1 divided by 1 plus 1 divided by 1 plus, and so on and so forth? So I'm going to be a little cavalier about it, but you can make it absolutely precise. There's a trick. So the hint is part of this denominator is in red. But the part of this denominator that's in red is exactly a replica of the entire number you're trying to calculate. So it's an example of a number that lives inside itself, if you can imagine what that means. That's just another way of encoding all quadratic equations. And so whatever this number x is, it has to be a solution to x equals 1 divided by 1 plus x, where x is positive, you can cross-multiply, use the quadratic formula, and there's only one possible positive value, and it's negative 1 plus the square root of 5 over 2, and this is exactly what that continued fraction converges to. Now, what do we do in mathematics? We don't all do that, but many of us do. As a theoretical scientist, if you are offered a glimpse of a beautiful theory, or if you're offered a beautiful formula, your first inclination might be to ask whether the formula that you're looking at is a special case of a bigger theory. If so, let's go find it. And so at the turn of the century, 19th to the 20th, the mathematicians of the world were certainly wondering about continued fractions. Been studied for over 100 years by that point. And in terms of a generalization, people had asked, and Ramanujan did also ask, well, can anyone evaluate these infinite continued fractions when you start inserting some variables? So here is r of q. This is what we now call the Rogers-Ramanujan continued fraction. And where do you insert the q? You insert powers of q as successive numerators in increasing order. So if you let q equals 1, you get back our trick, get the number minus 1 plus the square root of 5 over 2. But this trick doesn't work for like any other values of q. So the question is, can anyone evaluate r of q for any other values? So Hardy knew that this was a very difficult problem, unsolvable. And what Ramanujan ended his letter to Hardy with were 3 very famous lines, which basically boil down to the sentence, I can actually evaluate that function at e to the minus pi root n for every positive rational number n. Now let's just stop and think about that for a moment. Ramanujan wanted to evaluate this function at various values of q. And what would a normal person do? A normal person will say, let's plug in like the number 2. Or how about a half? Maybe if we're daring, we'll plug in 1/7. And if you do that with a computer, you're not going to find any beautiful formulas. We still don't know how to evaluate those numbers. But what Ramanujan understood is, well, maybe you have to insert some fantastically complicated numbers. So complicated that their true complexity meshes very well with this infinite process to then return a beautiful number. It won't be like the ugliest numbers you could ever come up with. A number is ugly by definition. Actually, I'm making this up now, but it might as well be in the book. A number is ugly if by definition you have to refer to it by some symbol, like pi. Pi by definition is 3.14, and it's a theorem nobody knows from some point on. The same is true for e. And so what Ramanujan thought, well, maybe I can combine them and try to evaluate this function at e to the minus pi root n. What could possibly be worse? And so he ends his letter with this set of claims. Incredible. So Ramanujan's notation for this function is different from what I'm using. That's what this stuff on the left-hand side is. And he says that if you plug in e to the minus 2 pi, that's for the q, what you get is this fairly familiar looking power of e. But what you get here looks a whole lot like negative 1 plus the square root of 5 over 2. It's a very elementary expression in the golden ratio, which is essentially the number I showed you a moment ago. And instead, if you plug in another power, like this, well, what you get is a number which looks a whole lot like the number I already showed you, manipulated through some elementary expression. And his last line is, and by the way, I can do this, compute this exactly for other quantities n. And Hardy had never seen anything like that, and it's kind of an incredible claim. The resolution of this claim wasn't done until the late 1990s, and Ramanujan, in his first letter to Hardy, ends with these incredible claims. All right, so let me show you how, in the film, we depicted Hardy's reaction to this amazing letter from this Indian clerk. Also in this scene, we are introducing one of Hardy's closest collaborators, his good friend John Littlewood, played by Toby Jones. And I hope you enjoy the scene. So the scene is about how the great Hardy reacts to this letter from an Indian clerk.
You know, this year alone, I've received correspondence from those who profess to prove the prophetic wisdom of the pyramids, the revelations of the elders of Zion, and the cryptograms which Bacon supposedly buried within the plays of the so-called Shakespeare. But a letter from an ill-educated Indian clerk in Madras challenging assertions I made in the track series really takes the biscuit.
I have to say, I've made similar assertions myself.
So you admit it?
And this was 3 years ago.
No, I'm talking about the letter. Bloody brilliant, I thought. I don't know where you got the postmark. Almost had me fooled.
I simply don't know what you're talking about.
Oh, come on. I'm not a complete idiot.
I don't know how to get this into your thick skull, whatever it is you're talking about, I'm simply not involved. Play.
So, you missed home. Last time we reached. I tell you, there is a war coming, no doubt about it. Because we are being led like mindless, spineless sheep. No one bothers to question any of it. It's coming all right, you can smell it.
You're as parable as Hardy.
With all due respect, Becky, you couldn't hold a candle. Littlewood, could I have a word?
Yes, of course. Intervals, infinite series, God knows what else. Oh, excuse me. Always forget you don't believe in the supreme being.
Right.
Well, this chap turns out to be genuine, you might have to reconsider.
It must be genuine. We have the imagination to invent all that.
More flatter than you thought I did. These two infinite series are the more intriguing.
Yeah, they defeat me completely. I've never seen anything like them.
But it's deceptive. I'll wager the hypergeometric series.
A great Littlewood stumped. He's hot class, I say. Being inexperienced, I would very highly value any advice you give me. Yours truly, S. Ramanujan.
What does the S stand for?
Ask himself.
You just reminds me here.
Oh, no. Much better. Let him rot away in his office in Madras, you know.
Right. So Hardy arranges for a fellowship for Ramanujan to study in Cambridge. Now we have to stop and think about that is extraordinary. I'm sure you can understand. India at the time was a British colony. And it actually, quite frankly, was not very pleasant to be Indian as part of the British Empire in those days. So there was, of course, a little bit of racism. And there's also the very, very interesting relationship that was the stuff of these two very different people. In Hardy, you had a distinguished Cambridge professor who you now have learned was an atheist. And in Ramanujan, you have a two-time college dropout from poor India who was an Indian who thought his ideas came to him as visions from God. What could be more interesting as just a story between two people who have to somehow find a way to get along together. I'm not very eloquent, but Jeremy Irons he had this spiel where he would describe that, where he described it as the most unique romance in terms of film. You couldn't have two more different people, an atheist and a Hindu, a distinguished Cambridge professor and a lowly clerk from India, and somehow they have to come together and make something out of something great. And what Jeremy liked to say is that it speaks to today, where unfortunately we live in an era where communities are getting driven apart. So he eloquently at the White House said, We need more science, and in the United States, science has largely been driven because of the people we've trained from all over the world, and we should be embracing that idea rather than beginning to clamp down on visas and NSF funding, so on and so forth. It was really incredible. I couldn't believe how fortunate we were to have him as a spokesperson. And he used this story as an example. So in this scene, I'd like to show it to you. The purpose of this scene was basically to emphasize how different these two men were.
Remember, we decided that for the good of everybody, you should attend some lectures.
But I'm here to publish.
Yes, one good time, I hope. But first we need proofs of your work.
It's really nothing to worry about. It's simply a question of acquainting you with the more formal methods that will benefit our future work together.
We need a common language. You wouldn't expect us to converse with you in town.
No. But you expect me to speak English.
Quite. So, there'll be plenty of time for publishing.
I'm sorry, but with all humility, how does anyone know that? I don't want this to die with me.
I'm sure you would work.
Thank you, sir. But I have much more to share with you. As I don't go, the letter only contains a small sampling of my discoveries. You'll see I have even found a function which exactly represents the number of prime numbers less than x in the form of an infinite series.
Exactly.
Yes, I thought if we were going to publish, it should be something groundbreaking.
This is most unexpected.
This will take a lifetime.
Maybe two.
I'm glad you laughed. I have a good friend who's a professor at the University of Illinois. His name is Bruce Byrne, and he is one of the people who has devoted his life to these notebooks. And it was with great trepidation that I said, okay, I guess we can put that line in. I hope my friend doesn't get angry with me, thinking that I snuck it in there to make fun of him. But in any event, thank you for chuckling. Okay. So one of the features of this Ramanujan Hardy story that made it so powerful is that it speaks to anyone who's either been a parent or a teacher, or certainly everyone who's ever been a student. You see, to succeed in life, everyone needs help. Nobody just makes it by being themselves. Everyone needs some help. And in this case, Ramanujan needed help from Hardy, despite the fact that he was brilliant, despite the fact he was coming up with formulas by himself. And what made it very difficult for the relationship was that Hardy didn't actually know how to be a great mentor. He wanted to do mathematics, and he was very rigid about how mathematics was supposed to be done. And for these two people, that was a huge conflict. One of my favorite scenes in this film, which I'm about to show you, is about that very complicated relationship. When Hardy finally recognizes how he could be the best possible mentor for someone like Ramanujan. And that was to explain to Ramanujan that they both have a responsibility for the sake of science to see that his work is confirmed and is published. Which is not the kind of conversation you typically have with a student in these circumstances. So let me show you this scene. And of course, when you're filming in Cambridge, and in this case Oxford, the library that we used was in Oxford, it's just beautiful. The cinematography doesn't need any help when you've got those surroundings. Oh! I have 50-year-old eyes, so there's a little triangle and it's suppressed.
How do you know that theorem?
Mr. Hardy, I don't understand why you waste our time doing all these proofs. I have the formulas.
It's not that I can't see what you've claimed. It's that I'm not sure that you know how you got there. Or indeed that your claims are correct. There are subtleties which...
But they are right, sir. I have more important new ideas.
The intuition is not enough. It has to be held accountable. And a little humility would go a long way. Why do you think they want us to fail?
Because I'm Indian.
Well, yeah, there is that. But also because of what we represent. Now, Euler and Jacobi, who were they?
Mathematicians.
Just names to you. Euler was the most productive mathematician of the 18th century. Most of his work done after he was blind. Jacobi, like you, was snapped from obscurity and was almost as impressive as Euler. Now, I think you are in their class. What they had in common, what I see in you, is a love of form. It's all through your notebooks. Let me ask you something. Why do you do it, any of this?
Because I have to. I see it.
Like what? Form for its own sake. An art unto itself. And like all art, it reflects truth. It's the only truth I know. It's my church. And you, just as Mozart could hear an entire symphony in his head, you dance with numbers to infinity. But this dance, this art, does little to endear us to certain factions who see us as mere conjurers. So if we are going to challenge areas of mathematics that are so well trod, we cannot afford to be wrong. I need you to attend your lectures, don't offend your professors, and keep doing your proofs. Otherwise this experiment of ours will be doomed to failure. Come with me. I want to show you something. There are many ways to be honored in life. For us, being elected a fellow is certainly one, but in my humble opinion, to leave a legacy here at the Wren after we're gone is the greatest. This library houses the epistles of St. Paul, the poems of Milton, Morgan's Bible. But in my estimation, as a man of numbers, the pièce de résistance is Newton's Principia Mathematica. Now, just as Newton represents the physical aspect of our work, your notebooks represent the abstract. It took a long time for Newton to be proved, which is why we have an obligation to prove these. And if we do, I believe that one day, these notebooks will find their place here. Now, do you understand what's at stake here? Good.
Great. I really love that scene. It's actually two scenes assembled together. For those of you who are mathematicians or math students, I hope you appreciate the great care we took in terms of describing how a mathematician thinks. So let me just remind you of some of the words. It's not that I don't understand your claims. It's not that I don't understand your claims. I don't know that you know how you got there, or indeed that your claims are correct. There's a method, there's all this stuff about proofs. We spent an entire morning on a Friday writing that scene because, and that was part of my job on the script. Jeremy Irons would say, I'm G.H. Hardy. What does it mean to say that I don't understand this kid's notebooks? Well, there's a process. That's why we have all these proofs. You're going to see it throughout the script. Proofs, proofs, proofs. And I really appreciated the fact that the cast wanted to get that right. And, they said several times, we're actors. We have to fake it. We have to rely on you. So it's really important that we get this right. And it was crazy. I never thought that I would be giving lectures on the fundamental theorem of calculus to people who didn't care about calculus, but trying to make a point so that they could then pretend to be math professor and student. And I really appreciated that. They didn't have to take that care. By the way, if you're wondering, those notebooks that the art department produced, every page was reproduced from the original. It wasn't like 5 or 6 pages, every single page. We had about a dozen copies of Ramanujan's first letter to Hardy, delicately prepared by Liz Colbert. She's actually very famous in Hollywood. And her only job on set was to master Ramanujan's handwriting. So she spent a whole week writing Ramanujan's letters and some of his notes. It was pretty incredible. So how does the story end? Well, Ramanujan in his time in England wrote 30 papers on the party. Try to remember what this time period was. It was the mid-19 teens. This was the time of World War I. And of course, as an Indian, part of this colony that was basically entirely subjugated by the British elite, he had to overcome many obstacles: racism, lack of foodstuffs. In fact, he was a vegetarian. Who in England was a vegetarian then? And despite all of these hardships, for his field-changing work, he was elected Fellow of the Royal Society. As an Indian, in his early 30s, he was elected, and he was the first Indian scientist to be elected to the Royal Society. He earned this great honor. He was actually elected in 1918. This year is 2018. There are many distinguished scientists that are in the Royal Society. Start with Isaac Newton. Think Rutherford. There's a long, distinguished list of famous scientists who are members of the Royal Society. It's a great thing, actually, when you go to the Royal Society. They'll show you the books where people have signed, and you can see, like, Newton's signature. But the point I want to make is, the Royal Society this year has decided to hold a gala event, major event in October, to celebrate the 100th anniversary of Ramanujan's election. Think about how amazing that is, because if they did that for every important scientist that was a member of the Royal Society, there would be no time for science. Today's science. I think it says something. So I'm delighted that that's going to happen, and I think it'll be super. In fact, we will be screening The Man Who Knew Infinity there at the Royal Society, and with some luck, some of the cast will come and maybe share some of their stories. After all, many of the members of the cast live in the area. There's tragedy, unfortunately. That's also one of the reasons this film was made. There's a lot of angst, there's a lot of emotion. Ramanujan fell ill during his stay in England. In 1919, he returned to India hoping for a return to good health. That wasn't to be, and he would die within the year. He died in 1920 at the age of 32. He continued to produce mind-blowing math from his deathbed. How true is that? Well, I'll get to that in a moment. But I do want to say a few things, very, very briefly, to leave you with some indication of some of Ramanujan's beautiful mathematics. Some of it is so technical that I wouldn't be able to do it justice, but this is easy to do. Ramanujan was the first world expert in the additive theory of partitions and number theory. It looks like child's play. I could ask you the question, in how many ways can you add up numbers to get the number 4? Here I've exhibited all of them to you. We don't count reorderings as different partitions. So here are 5 ways of partitioning 4, and that's rewritten as the evaluation of this function p at 4. So we say p of 4 is 5. If you carry out this kind of procedure, write all the partitions of 8, 16, and 32, and then count the number that you get, the values of this function grow at an astronomical rate. There are 22 partitions of 8. There's 231 partitions of 16. There really are 8,349 partitions of 32. Just to emphasize what we're talking about there, 32 is the first partition of 32. 31 plus 1 would be the second one. I have 8,347 to go before I finally list the last one, which is 32 copies of 1. It's an astronomical task. What did Hardy and Ramanujan prove? They in fact invented a method. It's called the circle method. It's still being perfected today for various applications. And their theorem is that this partition function that seems like mere child's play is anything but. It's an extremely complicated function. And its main term, what gives the size of p of n, is very unfriendly. The number of partitions of n behaves like 1 over 4n root 3 times there's e again, e to the pi again, e to the pi root 2n over 3. What does this mean? It means if you substitute in larger and larger values for n into the right-hand side and divide those values into the actual p of n value, those numbers will converge fairly rapidly to 1. Okay. So this method, called the circle method, is now a fundamental tool in mathematics, and as I said, people are still perfecting it. If you hear about theorems related to problems like Waring's problem, most of the state-of-the-art results depend on some variant of this method. And as a teenager, this beautiful theorem, believe it or not, inspired much of my own work, and it still has inspired my work to this day. I'd like to view this function p of n as a testing ground for deeper theories. So what do we actually learn from Ramanujan? There's a number of things. In mathematics, we learn a lot. Many people have won some of the most distinguished prizes that are available to mathematicians. Andre Weil was a longtime professor at the Institute for Advanced Study. He loved Indian culture, and he was one of the first people to trumpet Ramanujan, and he did so by the 1950s. And inspired by a paper that was called On Certain Arithmetical Functions, which doesn't sound imposing at all, Andre Weil was able to formulate some of the deepest conjectures at the interface of algebraic geometry and number theory. The last of these conjectures to fall was proven by a Belgian mathematician by the name of Pierre Deligne. It's called the Ramanujan-Peterson conjecture, and Deligne won the Fields Medal for it. And I think even in the conference that's here this week, people have talked about variants and applications of this type of mathematics. Wardridge won the Fields Medal for something called monstrous moonshine, which is now at the forefront in string theory and mathematics. And even the proof of Fermat's last theorem owes some of its ideas to Ramanujan, because Weil's proof of Fermat's last theorem makes use of what are called modular Galois representations, which is a subject that Serre began to see glimpses of when he was studying Ramanujan's notebooks in the Collège de France. What else do we learn from Ramanujan? Well, if you have a cell phone, you can thank Ramanujan for helping make your cell phone work a little bit better. This is my friend P.P. Vaidyanathan. He is a professor at Caltech in electrical engineering. He works in what's called graph signal processing, and he found a way to make use of functions called Ramanujan sums that we use in number theory quite frequently, but he found a way to put them to good use in signal processing. Signal processing is the science and engineering of cleaning up or removing errors from messages that have been transmitted. So think cell phones, think satellite communications. And this is very recent. His innovative idea of using the Ramanujan sums won him the Kirchhoff Prize from IEEE, which is one of the most prestigious prizes an electrical engineer can win. Ramanujan, in his last letter to Hardy, which he wrote from his deathbed, he was dying, he was still doing mathematics, begins with words that have inspired much of my work. This letter begins with, "Dear Hardy, I'm extremely sorry for not writing you a single letter up to now. I've discovered very interesting functions recently, which I call Mach theta functions, and they enter into mathematics as beautifully as the ordinary theta functions. Although this letter was written in 1920, it would be over 80 years before the mathematicians could figure out what he was talking about." This is me standing in front of Newton in the Wren Library, and I'm actually holding that letter. The letter which began with those words goes on to have a couple pages of mathematical formulas that we've only been able to recently figure out. And if you've seen our film, you might remember one of these closing screenshots where the caption is, "A century later, these formulas are being used to understand the behavior of black holes." This is no exaggeration. Ed Witten, who is a Fields medalist and actually perhaps the most important theoretical string theorist, he's a professor at the Institute for Advanced Study. About 10 years ago, he made a proposition for what should be the formulation of three-dimensional quantum gravity. Just in a few sentences, one of the major problems in physics is to bring Newton's laws of gravity in sync with Einstein's theory of relativity. Einstein's theory of relativity work very well in certain scales, and Newton's laws of gravity, they help find planets. What is the transition theory? So in a nutshell, that's what three-dimensional quantum gravity is aimed at providing for us. Well, that theory is now being informed by Ramanujan's Mach theta functions, and has a lot to do with what's called the distribution of multi-centered black holes, which you may have even seen some news clippings about in connection with the discovery of gravitational waves. You may have seen some cartoon images of black holes colliding into each other. My friend Don Zagier has written some papers where they have modeled the distribution of these gadgets. Why does Ramanujan matter? He's a great role model for students. He's a great role model for the idea that bringing people together from two different cultures can produce something amazing. In terms of science, this is the idea of Ramanujan. Together with one of my PhD students, Robert Schneider, we wrote a little essay, and in this essay we wrote the following words. We wrote, Ramanujan matters because he represents endless curiosity and untapped potential, which we all have to believe in to proceed in the sciences. Science usually advances on the work of thousands, over generations fine-tuning and extending the scope of understanding. But from time to time, creative fireballs like Ramanujan burst onto the scene, propelling human thought forward. There are very few people in this category. Think Einstein, think Newton. And for us in number theory and certain areas in mathematical physics and now electrical engineering, you should be thinking Ramanujan. So the lecture was, why does Ramanujan matter? I think he matters for all of these reasons. And when we screened the film in California to the breakthrough people, Mark Zuckerberg and Yuri Milner and Jack Ma, I was on stage with the cast for a Q&A at the end of the screening. And I actually don't know what got into me. I got excited. I wasn't jet lagged then. And I think I said something like this. I think Ramanujan, this is why, so if you don't know who the breakthrough people are, they give out lots of prizes to distinguished scientists. And they fund SETI, and at the time that we were at their compound in Silicon Valley, they had just announced something called Breakthrough Starshot. They are funding this project to send thousands of little spaceships out to Alpha Centauri to seek evidence of extraterrestrial life. Maybe you remember this in the news. Stephen Hawking was there, and it's kind of a big thing. So I got carried away. So the screening of the film was the social event for that week's conference. And I said something like this, like you guys, like SETI, seeking evidence of extraterrestrial life, we have an important task here. We should be searching Earth for like smart people. We should be searching Earth for the next Ramanujans and the next Newtons and the next Einsteins, because science depends on it. Well, to make a long story short, a few minutes later, Andrew Sarrazin, who is the president of the Templeton World Charity Foundation, came up to me and said, I'm going to give you $100,000. Prove to me you can find some smart people that would otherwise be lost. Prove to me you can find some Ramanujans. So we've been doing this, and I'm very delighted that we found some incredible people. Our pilot program was very successful, and they just gave us another $500,000 to start giving away in the fall. And yeah, so for me personally, everything about Ramanujan has led to something very good. We're actually going to the Vatican later this year to help work with them in terms of some of their educational missions, and it's kind of been an incredible story. All right, so that's what I have to say. Thank you very much.